Hello, my name is Ashish Kumar and I am a third year BTech student at Govind Ballabh Pant Institute of Engineering and Technology. Along with my team member Himanshu Sanwal and Rohit Bogna, we are excited to present our project to you. I am thanking Emertxe Information Technology for providing me this wonderful opportunity. So I completed my internship on IoT from Emertxe Information Technologies, and during this internship we built a project called IoT, basically home automation solution. I am going to give presentation over this project and what we learned during this internship program. Going to the next slide. This is the content slide and these are the contents which I am going to present, and also these are the topics which are learned during this internship program. In this internship program we learn about C programming, IoT, embedded system, microcontroller and so many topics. And in this project section I am going to discuss about overview of our project, objective of our project and design element of our project, like how to design our project to get the desired output and so on. Go into the next slide. This is C programming. C programming is a general purpose language, even though it is applied and used effectively in various specific domains. In this figure, we can see a structure of simple C programming. The first line contains file header. This file header contains title of the program, author name, date and place. And this type of information it's. And the second line is preprocessor directive. Preprocessor directive is the first stage of compilation, and then intermine is the main function, and then in curly bracket we can write our project. And these are the topics that we learned during this internship program. So we learned about the data types. There are basically 4 data types. Character data type which acquire 1 byte of memory. Second one, integer data type which acquire 2 or 4 bytes of memory, and float data type which acquire 4 bytes of memory, and double data type it acquire 8 byte of memory. And then we also learn about the modifier and qualifiers, and we learn about array is a collection of same type of data types, and we learned how to create array and how to declare array and how to initiate or initialize array. And we learn about functions, how to define a function, type of argument and number of argument given to the function. And we learn about pointer is a variable that holds the address of another variable. We learn about pointer arithmetic, and we also learn 2 methods. They are passed by value and passed by reference. And we learned about the string. A string is an array of character ending with a null character. And we learn about the preprocessor, macros, and advantage of using macros over the functions, and so on. And we learn about the user defined data type, and C plus test programming. C++ is a procedure oriented programming language.
Myself, Himanshu Sanwal. Now I am going to talk about what is IoT, embedded system, and project overview. In this slide, I am going to talk about what is Internet of Things. The Internet of Things describes the network of physical objects things that are embedded with sensor, software and other technology for the purpose of connecting and exchanging data with other device and system over the internet. In this slide, we can see that how Internet of Things is used in various fields and domains. For the example, in this figure, they are give that Internet of Things is used in logistics, healthcare, manufacturing, TVs, mobile phone, home monitoring, home appliance, and home automation system, and it is also used in heavy machinery and transportation. IoT is a collective network of connected devices. IoT technology that facilitate communication between device over the internet. IoT system work through the real-time collection and exchange of data. And in this slide, we can see some of the application and example for Internet of Things. Application are as in previous slide. Internet of Things can be used in automobile, manufacturing industry and logistic and transportation industry, and it also used in business also. Now I am going to talk about what is embedded system. An embedded system is a combination of computer hardware and software designed for a specific function and specific task. And a better system are low cost, low power consuming, small computer are connected in other mechanical or electrical devices. Generally, embedded system comprise a processor, power supply and memory and a communication port. And in this figure, we can see the basic block diagram of embedded system. Embedded system consists of first sensor, analog to digital converter, processor and ASIC. ASIC stands for the application specific integrated circuit, digital to analog converter, actuator and last memory element. Sensor. What is sensor? Sensor measures the physical quantity and converts it to an electrical signal which can be read by and observed on an electronic device or instrument. Analog digital converter convert the analog signal sent by the sensor into a digital signal. Processor process the data to measure the output and store it to memory. Digital to analog converter converts the digital data feed by the processor to analog data. And last, actuator compress the output given by the digital to analog converter to the actual or expected output and store the approved output. And in this slide, we can see where we embedded system. The embedded system apply for medical field, electronics, robotics, security system, telecommunication, automobile industry and so on. Then we learn about the part of component of embedded system. The embedded system basically contains three parts. First, SoC. SoC is stand for system on chip. Second, microcontroller and microprocessor. And then last, memory element. What is system on chip? A system on a chip is an integrated circuit that combines many elements of a computer system into a single chip. A SoC always include a CPU, but it might also include system memory, peripheral controller for USB storage, and more advanced peripheral such as graphic processing unit GPU, radio, modems for Bluetooth or Wi-Fi and more. Second, microcontroller contain ADC block and digital to analog converter block. Second, timer and counter pulse. Third, PWM stand for pulse width modulation. Preprocessor, memory and input output port. And we also learn about microprocessor and various microcontroller and their advantage and similarity and so on. And we also learn about memory element. In that we learned RAM, ROM and types of RAM and types of ROM. And we also learn about peripheral devices. Peripheral is internal or external devices that connect directly to the computer or microcontroller in this project. We use so many peripherals like LDR sensor, CLCD to display the output of sensor and a temperature sensor in serial tank. In this slide, we are going to discuss about overview of our project. Our project provide an IoT based home automation solution using Arduino Uno board in PixSim Lab simulator. And Blynk IoT mobile application is used to control that device remotely. We can control the light and temperature of the room or home and inflow and outflow of water in the water tank using Blynk IoT app. In the next slide, we are going to discuss about object of our project. Connect the home appliance to the Arduino and integrated it with Blynk IoT app using Blynk Cloud. Control light, temperature of home along with the level of water tank using mobile app. Obtain notification about the status of home on the mobile phone. And in this we can also monitor or get the details other devices we are controlling. And the next slide, why home automation? Generally people also don't say stay at home. This problem of home appliance not being monitored. The solution for this problem comes out to be home automation. Home automation enables people to control most of the devices remotely, such as volume of the water present in the water tank, garden light, temperature of the home. So on we Arduino Uno. So we are going to discuss about it. Arduino Uno is a microcontroller board based on Atmega 328P. It has 18 digital input and output pins. In that 6 can be used as pulse width modulation PWM output and 6 analog input output pin, and these 6 PWM pin are also called as digital pin, and it contains a 16 MHz resonator and a USB connection, a power jack to power supply, and a reset button. Arduino can be programmed using different IDE, and in our project we use Arduino IDE. IDE stands for Integrated Development Environment. Arduino IDE support C and C++ language, and we also use the PixSim Lab. PixSim Lab is an open source real-time emulator of development board with integrated GDB debugger. It supports some PixSim microcontroller and some other microcontroller also. It has integration with Arduino IDE for programming the board microcontroller. In next slide, we use Blynk IOT app, and we also learn how to configure this app, and we learn how to create a new template, how to add device, how to select and add data stream, how to create icons, and how to include Blynk library, and so on. And the next slide, LDR. What is LDR? LDR stands for light dependent resistor. Earlier is a 2-pin devices, and in this figure we can see the resistance sources and the light intensity graph. As the light intensity increases, the resistance across the LDR is decreases. So LDR sensor is light detecting sensor that detect the light that falls upon it. The photoresistor is a light controlled variable resistor. The resistance of a photoresistor decreases with increasing in incident light intensity. The LED light are connected to the LDR via the analog to digital converter. The analog to digital converter convert the analog input by the LDR into its equivalent digital form, which is then convert later by certain formula from 0 as the lower bound to 255 as upper bound, and based on that we grow the LED. For example, if the 255, then LED will glow to full of its brightness. If the output value is 0, then LED it will be completely off. And this is how we are using LDR to control the garden light. We connected LDR sensor and LEDs to Arduino Uno. The properties of LDR sensor is applied to accomplish the controlling of garden lights. During the day, the outdoor light is maximum, so the LDR sensor detects the light and the garden light is turned off. Whereas the night time, the outdoor light is very low, so the LDR sensor detects the low light and the light is turned on. And the next slide, temperature sensor. The temperature sensor is 3-pin device. First is VCC 4 to 20 volt, second out pin, and third is ground. The temperature is recorded using LM35 sensor, which reads analog value. The value is converted into binary value and later actual temperature is calculated using the obtained value of the voltage. The sensor does not require any external calibration or trimming to provide accuracy of plus minus 0.5 degrees Celsius at room temperature and plus minus 1 degree temperature over the minus 50 degrees Celsius to plus 155 degrees Celsius temperature range. The output scale factor of the LM35 is 10 millivolt per degree Celsius. For instance, it provides an output voltage of 250 millivolt at 25 degree Celsius. And the next slide, temperature control system. The temperature control system consists of a heating resistor, an LM35 temperature sensor, and a collar. Analog value of temperature is obtained from the temperature sensor LM35 and display it on the CLCD after converting it into digital value using A to D converter. Control the temperature of the system by turning on off the heater and cooler through the Blynk IOT mobile app. And then water tank inlet and outlet valve control. Read the volume of the water in the tank through serial communication and display it on the CLCD. Control the volume of the water in the tank by controlling the inlet and outlet valve by sending command through serial communication and display the volume of water in the tank on the CLCD and also in Blynk IOT app. The tank refills itself when the outflow exceeds the threshold of minimum value 2000 liter and it stops filling when the tank is full at 3000 liter. Gives notification to Blynk IOT app. And the next slide is simulation image for home automation project. And the last conclusion. In summary, this project provides a solution of monitoring and controlling home appliance and certain device remotely using Blynk IoT application and PixSimLab simulator. Home automation project is simulated where LED, temperature system, serial tank, assemble, light, heater, cooler, and water tank in real time. Blynk IoT application allow user to control these devices according to user's wish, thus accomplish home automation. Thank you.
I am Rohit Bahuguna and I am going to explain the IoT Home Automation project. This is the code we have used in our project. The Blynk IoT app helps us monitor our code from a mobile device. The first part of our code is for the temperature system. When the temperature exceeds 35 degrees Celsius, which is not normal for room temperature, the heater should turn off. Similarly, When the temperature drops below 28 degrees Celsius, which is considered the normal room temperature, the cooler should turn off. This is the second part of the code, the temperature system. The third and last part of our code is about the serial tank, which when the tank volume falls below 1500 liters, the inlet valve should automatically turn on and a notification should pop up indicating that the water level is below 1500 liters. The maximum level of the tank is set at 3000 liters. When the tank reaches 3000 liters, the inlet valve should turn off. Also, when we turn on the outlet valve, the water should flow in opposite direction. Now, let's move on the first part of our code, which is about garden lighting. We have used LDR, that is light dependent resistor here. When the resistance of the LDR is high, indicating that the garden light should turn on, the LEDs will go. Conversely, when we decrease the resistance of the LDR, indicating daylight, the light should slowly turn off. The LED will turn off completely. The next part of our project is about monitoring the temperature in a home. We are using the Blynk IOT app to monitor it from our home device. When I turn on the heater, the temperature should rise until it reaches 35 degrees Celsius. If the temperature exceeds 35 degrees Celsius, that heater should turn off automatically and we should receive a notification on our mobile screen. Similarly, if I turn on the cooler, the fan will start rotating. The temperature will decrease. The cutoff temperature for the cooler is set at 27.9 degrees Celsius. When the temperature reaches or falls below this cutoff, the cooler should turn off and a notification will appear. Finally, let's discuss the last part of our code, which is about the serial tank. The maximum volume the tank can store is 3000 liters. Initially, the tank is completely filled with water. The inlet valve is currently off since it is already full. When I turn on the outlet valve, the water should flow in opposite direction, emptying the tank. The cutoff we have set for the tank is 1500 liters. Whenever the water level falls below 1500 liters, the inlet valve should turn on, and a notification will appear indicating the low water level. We cannot turn off the inlet when the water level is below the cutoff. If we turn off the outlet, the water level will increase again and a notification will pop up when it reaches the maximum capacity of 3000 liters. That's conclude our project overview. Thank you.